Hello, and welcome to yet another retro channel. As promised, today we'll be looking at another of my retro virginities and knocking that one off the list. It's a machine that I've never owned, barely ever touched, certainly have never worked on. I may have played a game or two on one in the past, but that's the extent of my experience. So, you'll be learning right along with me, and I guess without further ado, now, there are a lot of machines that I've never touched. Any of the Atari XL or XE series, Commodore Amigas, pretty much anything in the TRS-80 line, apart from the color computers and the Model 1 that I first touched as a kid. Quite a few British computers, Oric 1, Oric Atmos, BBC Micro or Master, Grundy New Brain, most of the later Sinclair and Amstrad machines. I've really never worked on any Soviet clones, so this could be pretty much anything. But it is, in fact, a Macintosh 128. I have had this one in my to-be worked on pile for almost a year now, and I have never so much as plugged it in, let alone powered it up, so I don't have any idea what condition it's in. My luck, it'll just work, but we're not going to know that for a while, because what I intend to do is tear it down to its component systems, the CRT, the analog board, the floppy drive, the main logic board, and work on each of them individually to make sure they work before putting the whole machine back together and trying it out. I don't even know for sure if this is simply a Macintosh 128. There were upgrade paths where you could turn them into Mac 512s. I even believe there was a way to put a hard drive in them, but I don't know right now if any of that's been done to this machine. And as for my knowledge of the machine and how it works and how to fix it, well, most of that's going to have come from other YouTubers. In particular, I've spent a lot of time watching Adrian Black's videos on Adrian's Digital Basement, but some other folks as well. I don't expect this machine to need a full recap, as this machine was built in 1984, and that was well before the capacitor plague. So I expect the caps are probably okay, but we'll take a look at them anyway as we go through it. And I'm going to be taking some precautions as to safe handling of the machine to make sure that I don't get zapped or, even worse, unalive myself. Wouldn't want that to happen. As you can see, when I bought this machine, it came with the keyboard, the mouse, the external 400K drive, of course the machine itself, and it even came with the canvas bag that Apple sold. I never even knew those existed until I got this machine and it was in that bag and I looked it up. This one is missing the battery door on the back, but of course that's an easy fix. All I have to do is 3D print one of those. Those STL files are available on, I believe, both Thingiverse and printables, so you can find those if you need them. As you can see, this machine is pretty well yellowed and the case is a bit dirty. It'll need some cleanup, but that's the last thing I'll take care of. If we look on the back, you'll see that it is missing its battery compartment door. There is only a small amount of green crusty corrosion in here, so I'm hoping that means that the battery hasn't leaked particularly badly and done damage to the analog board. The serial number, I believe, is under the lip, is F4183AZM0001. The M0001 is the model number. That serial number can be looked up online to tell you a little more information about it, and when I did so, I found that it was manufactured in 1984, so this is a very early Mac 128. I would expect the disk drive to be dirty, all the lubrication to be dried up, so I probably need to do a full restoration on the drive. It may also need, probably also needs, the cog in the eject mechanism replaced. Those are a common failure point. And I did go ahead and order some of those, so I have them at the ready when it's time to do that. Of course, you all know the story of this machine. I don't need to go through it again, how the 1984 George Orwell themed commercial ran during the Super Bowl, and how that commercial changed advertising, and how the Macintosh changed the face of the PC environment back then. So I won't go into the story. But we're going to go ahead and get inside this thing. And to do that, I need to get some protection and some tools. So we'll be back in just a moment with that. Okay, so the first thing I needed was a change of wardrobe. Can't work on an Apple product without the Apple shirt. Second thing is a towel. Now, I don't have a 70s towel, so I'm afraid I'm going to have to disappoint you there. This is just a regular bath towel. And I am going to put this on the bench underneath the Mac so that I can lay it down on its face without doing any more harm to it. And now we need to start removing some screws. I'll be honest, these are not the right screws. Screws here, here, and here, and they should be T15 Torx screws. However, they're flatheads. Now, I've had this machine for almost a year, and I've never had so much as a power cord plugged into it, never been plugged into the wall. There should be no dangerous voltages inside. However, there could be, so you're probably going to see some health and safety gremlin pop up a big old warning on the screen. What did I tell you? But it is worth paying attention to, because there could potentially, if you're working on a Macintosh, be voltages inside that could do you a mischief or even unalive you. So, I'm going to go ahead and take precautions before I start this. So the first thing I'm going to do is, I'm already wearing rubber-soled shoes. I'm going to put on a pair of insulated gloves. And once I'm inside, I'm going to try to only touch things one hand at a time until I'm sure that there are no dangerous voltages. Now, as I understand it, again, I have no experience at this. As I understand it, the best way to get this case off is to sort of pop it up. There we go. Got it. Okay. And our first look inside. The machine looks dusty, but largely intact. Now, the next thing we need to do is start taking the bits apart. So what I'm going to do to discharge the anode cap, or to make sure that it's discharged, because I'm pretty sure it's already empty after a year, is I'm going to do what you're not supposed to do. I'm going to use a screwdriver to do this. And this is a bad idea. I'm going to hook the screwdriver to the ground strap with clip lead and a very high-powered cable. And I'm going to lift the anode cap with a plastic device and insert the screwdriver under the cap to touch the contacts inside. The reason that this isn't a recommended procedure is that without a discharge or bleed resistor in the circuit, the potential in the tube, if it's charged, can be enough to cause an arc to go from the screwdriver's shaft to your hand, which can be obviously very dangerous. Next, I'll remove the anode cap with the help of the same plastic pry tool. In case you can't tell, I've never done anything like this before. remove the ground. Okay. Now, what you see here, as I said, there are several different components to this computer, and we're going to look at them individually. This is called the analog board along the side. This handles both the power supply, power generation, and the driver circuitry for the CRT. Then there's the CRT, the neck board, the neck board or neck connector, the yoke, and all the adjustments. Below that, we have the floppy disk drive in this cage, and then the main logic board is on the bottom. Now, what we want, because what we're going to look at first is the main logic board, is we need to get that out. So, to do that, I believe first thing we need to do is remove this connector. Let's see. What do we have on the bottom? This is going to be interesting. We have tabs that come through the logic board on the bottom. That'll need to be bent out of the way, and they're soldered. Is that going to come out? That'll come out. I think we just need to, well, if we had the connector off, we're going to get the connector off first. There we go. And now the logic board should slide out. Oh, wait, floppy drive connector. Got to get that out. Now it should slide out. Yeah, it's a little more difficult than usual because there is an upgrade. We have an upgrade board by Mac Memory Inc. called the Max. HM50256, and there are 4 banks of 8 of them. Okay, according to the datasheet, these memory chips are HM80256, and they are 256-bit by 256K times 1-bit dynamic RAM chips. So with 4 banks of them, this is a 1 meg expansion. Well, since we're going to work on the rest of these bits later, we're going to set this to the side. Now, how, you ask, are we going to work on this logic board without the power supply and without the CRT? Well, if I have done my job correctly, I have a solution for that. So I wired up this harness. This should fit onto the header here that the logic board was connected to the analog board by. Before we get into doing that, I should, as a precaution, I can get rid of the insulated gloves now, should take the precaution of reflowing the pins on this connector. And so I'm heating up my soldering iron. I don't see any obvious damage, but it couldn't hurt to give it a reflow. Okay, so what I have here is a power supply in adapter along with a video out. Power plus 12, minus 12, and plus 5 come in on this connector, and video and speaker out come off of this connector. So what I've done is I've wired up an ATX connector, which used to be an ATX extension cable, wired that up to the connector that connects here, and taken the video signals, H-sync, V-sync, video, and ground, to a DB9, which should let me connect up, if everything is wired correctly, let me connect up to the RGB to HDMI. I need to bring up the monitor. Power up the RGB to HDMI. I theoretically already have that set to the Macintosh 128 and 512 profile. Don't know if this is going to work. I did check and make sure the right voltages are on the right pins here. This connects this way to our logic board. Although I did wire it backwards, I think. I did. I wired it backwards. I should have had the lip end facing this way. Alright. Now all that's left to do is plug the 12 volts DC power supply into the ATX, the Pico ATX power supply that I'm using in this case. Here goes nothing. That's not great. All I'm getting here is a white screen. But it's a red herring. Remember when I said I had the video lead wired to the wrong pin on the DE9 going to the RGB to HDMI? Yep. As a result, all I get is a white screen no matter what. If I had a working Macintosh that I could have used to validate my capture setup, none of this would have happened. Sadly, all I have is this single lonely little Mac. Were it wired correctly, I would actually be getting a sad Mac icon with a memory error code. I'll figure all this out in a little while. In the meantime, I'm going to go down a few blind alleys, so please be patient with me. Okay. We could have problems in all kinds of different places here. So, it's been a while, actually, a couple of weeks since the last part of this video, and in the meantime I have been waiting for parts. That would be these two resistor networks. These are 47 ohm 5 isolated resistor networks, so 10 pins, 2 pins to each resistor, 47 ohms per resistor. These go in these two spots. I already had the brand new 74LS 244s that go in these two sockets. And the only other thing that I believe needs to be populated is if you look at the other side of the board at this position where this 7-pin header has gone in, you will find that it appears, as best I can tell, that there was a trace joining those two positions, and that's been cut. So you can see that right there, where it looks like it's been cut. I'm not 100% sure of that, but that's what I'm going by. So what I'm going to do there is I'm going to use a tiny, and I doubt you can see that, but if you can't, I'm going to use a tiny little offcut to bridge those two positions. Now, what I'm hoping is that that puts this board back into its original configuration. Now, I say original configuration. That may or may not be the case. I've also been doing some research, and in my research, I have determined that the original Mac 128 originally came with a motherboard that was designed specifically for the 128K. To be upgraded to 512, it had to have a multiplexer added and some pull-up resistors, along with simply changing out the DRAM chips from 4164s to 41256s. Later 128K boards were actually the 512K board, just configured for 128K, and it would accept both simply by changing out the DRAM chips, so there was no extra multiplexer needed. Now, Apple's policy, once they released the 512, was that they would upgrade your Mac from a 128 to a 512, but to do that, they would simply swap out the motherboard, which I suppose in their minds justified the $1,000 price tag for that upgrade. Even then, the memory wasn't that expensive. So this may be a swapped out 512K board, but honestly, these DRAM chips, based on the soldering at the top and on the bottom, looks like they've been swapped out. So I'm not entirely certain what's going on here. It is possible that this memory upgrade card that was on the board contains the extra multiplexing that's needed, because as I understand it, that multiplexing did attach here in this position, although on the original board this was simply vias. This header here has been added. So this may have been an original 128K board, and that's kind of indicated by this being a copyright 1983 revision of the board. So this may have been an original 128K. So in that case, we won't be taking it all the way back to its original configuration. We're going to take it back to try to take it back to a 512K configuration. So to do that, let's populate these things that are missing. That little offcut to bridge those two positions. The resistor networks, now it shouldn't matter which way these are put in because they are simply 5 resistors either way. It's nice that these sockets are here. I can just slip these in rather than having to solder them. And the two 244s go in these two positions. Now, one more thing that I did off camera while I was waiting for the parts was I did figure out that I had this wired incorrectly. This picks up the video horizontal vertical sync and the video signal and ground from the connector that connects here with the power and the video, and actually the speakers on there too. But this picks up the video and routes it to a DE9, which is then routed over here to my RGB to HDMI. I did notice something in editing. The video capture card that I was using to capture the HDMI from the RGB to HDMI didn't like the RGB to HDMI. So I've had to do some work on my video capture setup, and as a result, if I told you in the first part of the video that this is what something looks like, you never saw it. I never put anything up on the screen, and that's because it never captured anything. And even if it had been capturing with that wiring wrong, it wouldn't have been showing you anything useful anyway. So now the RGB to HDMI is hooked up correctly, and the video capture will be working. So, and I need a little spudger to get this thing on. This is the power and video and audio connector, and it plugs in again here. I've got this wired up backwards, so I haven't gotten around to fixing it yet. So I have to use a little spudger to wedge the cable connector down and sort of force it on. It's not ideal, but I'll fix it eventually. So now we should have all the power. This is just the audio signal. Don't worry about that. We should have power if we plug in the power to the Pico ATX, and if we're lucky, we'll get something on the display. And there we go. We are getting a SADMAC. And there is an error code there, although because it's a memory error, it's a little difficult to read. So this error code is 020400 to the best of my ability to read it. And if we look over on Tinker Different, there's a thread that tells us what these codes supposedly mean. So the codes, the first two characters tell you what class of error it was, and being 2, it's a memory test, bus subtest, and the rest of the digits, the last 4 digits, tell us which particular bit is failing. So 020400 going to be 0400. That is bit 10, and that's IC G7. So on this board, you have, just like with the old Apple IIs, the boards are labeled with a grid, letters down the left side and numbers across the bottom. So this is going to be G7, which is supposedly this chip right here. So we're getting a memory error that's telling us that this IC may be bad. There could be other things causing this, but the most likely candidate at this point is this IC right here. So what I'm going to do is I'm going to depower again, and I'm going to pull that chip, put a socket in, and get a new chip. And we'll test the old chip in a memory tester and see what we get. So, while the desoldering iron is warming up, I'm going to mark the chip so I don't get the wrong one. And G7 is this guy right here. So I desoldered the memory IC in G7, put in a socket, replaced it with a new IC. I have not tested yet. I took the old IC that was in there and put it in my memory tester and ran it, and it tested good. So this may not fix the problem, but we're going to give it a shot anyway and find out. So, gotta hook the power and video lead back up again. Okay. And we have capture ready. And let's see what happens when we apply power. Oh, one more thing. Let's see, let's unapply power. I borrowed the HDMI lead from the RGB to HDMI for the memory tester and forgot to put it back. So we have to wait for the RGB to HDMI to boot back up again. There we go. And now let's see. No. That didn't fix our problem. So, although it tells us that that memory chip is bad, that's not the fault, or at least not the only fault. So So we've got something wrong. We're going to have to dig deeper. Well, it's been a hot minute. I've been waiting on a couple of parts to proceed with this repair, and they finally come in. In the meantime, I've done more research, and I've done some diagnostics on the board, and I have found some things out, so let's talk about that. First thing in the research is I have figured out definitively now that this is an original Macintosh 128K board. It is not a replacement 512K board. This board has been modified. It has had its 64 kilobit RAM chips replaced with 256 kilobit RAM chips. That was probably done in the process of installing this 1 meg add-on card. It was probably done professionally in a shop, because the work that was done, the soldering on the RAM chips, is very nice. These two chips, the LS244s, were also removed from the main board. Sockets put in, well, socket headers were put in their place. I did have to replace one of those socket headers. I replaced it with an actual socket because one of the pairs of double wipe contacts was crushed in that. So this one is now a regular socket. This is still the socket headers. Those are replaced with sockets, and the original 244s, well, I don't know if the original 244s were moved or whether this board had 244s on it. These are the 244s now. And let's see. This board in this configuration, even with the 256 kilobit RAM chips in here, without a little extra work, this board should operate as a 128K RAM board. To get the RAM up to 512K, 2 additional address lines need to be accounted for, and those need to be multiplexed. But we'll get to that in a minute as well. So in the configuration it's in, it should operate as a 128K board. However, as we saw, I was getting an error that indicated a problem with bit 10. Bit 10 is the RAM chip in G7. I pulled that chip, socketed it, and put in a brand new chip. No change. And I did test the original chip, and it tested fine in my memory tester. So the problem wasn't the chip itself. So what I had to do is I had to go hunting for the problem. Now you do see this little mesh bodge wire here. What I found was that the RAM on board here, and I'm sure the RAM on the expansion board as well, there are 2 data pins on each RAM chip, pin 2 and pin 14. One's labeled Q, or one's labeled D and one's labeled Q. And I believe the original intent was that one would be an input pin and one would be an output pin. Now, most machines I've worked on in the past, such as the Commodore 64, simply tie those 2 pins together. That's not the case on the Macintosh. You have D pins, and the D's are pin 2, and those go to one data bus, while the Q on pin 14 goes to a separate data bus. Those are D0 through 7 for pin 2, and RQ 0 through 7 for the Q pin on 14. Now, what I found after a lot of digging and a lot of tracing traces on the board was that the D pin on pin 2 of the memory IC at G7, it's bit 10, pin 2 is supposed to connect to pin 14 on this 244. Now this is the 244 that I did not resocket, so the broken trace was not apparently due to something that I did, as far as I can tell. I would have been suspect of my work had it been this 244, which is the one that I did resocket, but I found no connection between pin 2 on the RAM chip and pin 14 on the 244. So this little bodge here actually makes this work, and we'll make that more permanent by putting a bodge on the back of the board here in a little bit. I couldn't find the actual break in the trace, and the reason for that is that in tracing all the traces, I hate saying it that way, in tracing all the traces, a lot of them go under soldered chips, and without desoldering the chips, it's next to impossible to trace every one and find where the specific break in the trace is. It isn't under these. I checked the soldering on the socket headers here, and the soldering is all fine. That pin goes to its first via. The pin 2 goes to its first via successfully. Somewhere in between those vias, where the track goes, there's a break. So the only way to fix it is going to be a bodge wire. Once that bodge wire is in place, let's see, are we all hooked up? Yes. Once that bodge wire is in place, as you will see here, the machine will start up without the memory error. And we get to the flashing question mark disk icon, meaning it's looking for something to load. Now, to show that it is in the 128K configuration, we do need to have an operating system to load. So I'm going to do that with the floppy emu. You've seen that before on my videos. I've used it with the Apple II. It also works with the Macintosh. You just have to put a new firmware on it. And we'll connect it here to the floppy interface. And that'll bring us up into the menu, and I'll need to set it to a system disk. I have to use a 400K disk, so we'll go with system 3.2. And I think we'll have to restart the machine. So I'll hit the reset button. We will also need a mouse. Now this mouse is not the mouse that I got with the computer. That's one of the parts that I was waiting on. It was a mouse. This is a serial mouse that goes with the early Macintoshes. What I was sent with the computer was this mouse, which unfortunately is an ADB, an Apple desktop bus mouse that won't work with this Macintosh. So I had to wait on a replacement mouse. But let's hook that up. And as you can see, now the system has booted. And the mouse is working, and I can go to About the Finder. And you'll see that the machine is, as I said, operating as 128K, even though we've got the 256 kilobit RAM chips installed. Now, how do we get it to operate as a 512? Well, that involves the addition of a multiplexer. I found an article from the Dr. Dobbs Journal, January 1985 issue, entitled Fatten Your Mac by Tom LaFleur and Susan Robb. And this details what you need to do to get your 128K Mac upgraded to 512K. And what you do is you replace the RAM chips and you add a multiplexer to pick up address bits 17 and 18. Now, that's the 68,000 addresses memory addresses as 1 through I think it's 24, 1 through 24 instead of 0 through 23. So when I say you're picking up address bits 17 and 18, you're actually picking up address bits 16 and 17 in the normal zero-based addressing scheme. But you need to pick those up, and you need to then multiplex them depending on which bank you're going to be addressing to get to both sets of 256 kilobytes. So the article goes into great detail, but it has these two drawings, these two diagrams, and they do it as what I would call a dead bug mod. What they do is piggyback the new multiplexer on top of another IC, solders to, I believe it's 4 pins. The VCC and ground pin and 2 other pins are soldered to the underlying IC, while the rest of the connections are picked up with flying leads and a couple of resistors from around the board. Knowing that this board already had this socket header in this position, I'm actually going to adapt their design to a small circuit board that plugs in here and doesn't need the flying leads going all around the place. So I'll be adding that multiplexer, and that will send that extra address line to pin 1 on each of the RAM ICs, which on a 4164 is unused, but on a 41256 is the extra address line. So instead of making you watch me build that, because that's going to take a while, I am, through the magic of editing, going to give it to you now. And there's our new little board already installed in the socket headers. So let's reboot the machine. All right, with the multiplexer board in place, Finder now says we have 512K. So this board appears to be working as a 512K board. Now, let's go ahead real quick and put the actual bodge wire on the back of the board and get rid of this little contraption here. That should be our bodge. I'll come back and tack that down later. Let's make sure we're still working. Okay, we are still set up as 512K. We don't have the clip-on bodge on the top. We have a bodge on the bottom. This should work. I need to reset the floppy emu again. There we go. Yeah. Yep, still 512K. All right, so the next thing to do is see about the 1 meg. Now, this should, being as it has 4 banks of 256K each, that should be adding 1 meg plus the existing 512K. That should bring this machine up to 1.5 megs of RAM. So, unpower, and we will take off the little multiplexer board that I added. Now, that multiplexing functionality it must be subsumed up here on the 1 meg board, the 1 meg board. And we need to remove the 244s. Because these pins go into those slots. We also need to remove these 2 resistor packs. And then slotting this into place should work. Have to get everything lined up just so. Everything seems to be in its proper sockets. So if everything goes well, I should be able to boot it now and get 1.5 megs. Still 512K. All right. Well, there's going to be a problem on this board then, and I'm not sure what that is. We didn't get a problem with the RAM. None of the signals on the address data bus look odd. Address or data bus look odd. We have 3 chips on this board that I don't know what they are. They may very well be PAL chips. They've been sanded down and have no identifiers on them. Pair of 253s. And then we have the 244s. We do have little blue caps, which I'm not overly fond of. Well, I don't know if I'm going to be able to fix this. I know I wasn't able to find any real information on this board, no schematics or anything, so it might be really hard to track down what's going on here. It seems that I'm getting all the signals from the board under the main logic board underneath. It's possible the ROM simply doesn't know that it can go to 1.5 megs. I'm going to have to search and see if I can find any more information on this board. We'll be back. Okay, I do apologize. I realized in the break there that I forgot to record the oscilloscope while I was testing the signals on the max memory board. just know that what I tested, everything looked good. There were no signals being pulled up or pulled down and held in position. They were all pulsing in what looked like normal ways. So I did a little more Google foo, and I found one article, actually forum thread related to this board, and it does explain a few things. It looks like the board may be working perfectly normally. The problem lies in how the original Mac ROMs work. They are only capable of seeing either 128K or 512K. For this board to work as a regular extension of system RAM, the ROMs in conjunction with the hardware would have to be able to identify that it was 1.5 megs, and the ROMs would need to set the screen buffers to the correct position at the top of RAM. Without doing that, the ROMs set the screen buffers to the top of the 512K, and that creates a non-contiguous block of system RAM, which the Mac is not capable of using that way. It has to be a contiguous block. So the way this is designed, it can only be used by specialized software that's able to talk to it. Mac Memory, the company that makes this board, did release software to use the upper 1 meg as a RAM disk. I don't have that software, or as far as I know, any other software that would use the upper 1 meg. So what I'm going to do, what I've decided to do, is take this board off, reconfigure this back to being a 512K board by putting the resistor packs back, putting the 244s back, and using the little multiplexer board that I built. So this machine will be operating as a 512. As I said, it was an original 128K board that has been modified, so now it's a 512K, and that should work correctly. There we go, 512K. So that's the way I'm going to use this board for now. We will come back possibly to the Max memory board at some point in the future, but for now we're going to leave this out of the machine. In our next video, we will cover the analog board and the CRT. Get those working. Once we have those working, then I will address the floppy drives, and then we should have a working Macintosh once we get all that together. So until then, you know what to do. If you like the video, give it a like, give it a thumbs up. If you didn't like it, you know what to do there too. Leave me a comment in the comment section below. I do love interacting with you guys, so comments are greatly appreciated. Share the video out to any of your friends that you think need to see it. And if you want to support the channel, the The links for my Patreon and Ko-Fi pages will be in the description, or you can join as a channel member on YouTube. That'll cover it. So everybody have a great week coming up. Stay safe and be well, and we'll see you in the next one. Thank you. And I have to tear this stuff down now.